All right, this is the solution video for section 9.1, problem number one. All right, so it says the number of bacteria in a culture increases from 5,000 to 15,000 in 10 hours. Assuming that the rate of increase is proportional to the number of bacteria present, find a formula for the number of bacteria in the culture at any time t. All right, so remember, assuming the rate of increase is proportional to the number of bacteria present, this is telling us that our y equals y sub 0 e to the kt is the equation or the solution to that differential equation, right? All right, and then it says estimate the number at the end of 20 hours. When will the number be 50,000? All right, so this is kind of a multi uh, equation, right? So first thing, it starts at 5,000 and goes to 15,000 in 10 hours. So the y value is going to be 15,000, all right, equals the y sub 0, which is 5,000, all right, and then e to the k times 10, right, 10 hours. And so we need to use that fact to find the value of k. So this is a relatively simple equation to solve. All right. And so I'm going to divide by 5,000. So 15,000 divided by 5,000 is just 3 equals e to the k times 10. All right. And so then I'm going to take the natural log of both sides. The natural log of 3 equals k times 10. And then k is going to be the natural log of 3 divided by 10. Right. So that's the value of k. So first it says find the formula for the number of bacteria in the culture at any time t. So that's very simple. Y equals 5,000 times e to the k, which is the natural log of 3 divided by 10 times t, right? So this is at any time t. So that's the first part. All right, next part, estimate the number at the end of 20 hours. Well, this is just a calculation. Y equals 5,000 e to the natural log of 3 divided by 10 times 20 hours, right? And so now this is just a calculation, right? So now we're going to do that calculation. So I have 5,000 times e. Okay, and then you got to make sure that this is all in the power. So then times the natural log of 3 divided by 10. All right, and then times 20. All right, and so we do that. Well, now that makes sense, right? Because you think about it, went from 5,000 to 15,000, right? And so then that's after 10 hours. So then after 10 more hours, it would triple again. All right. And so that would give us 45,000 bacteria. All right. What about the next one? When will the number be 50,000? So now we want to say, okay, well, if y is 50,000, right? And we started at 5,000, right? Times e to the k, which is the natural log of 3 divided by 10 times t. Now we want to solve for t. All right, so how do we do that? Well, we're going to start by dividing by 5,000. So 50,000 divided by 5,000, right, is going to give us 10. All right, and then I have e to the natural log of 3 divided by 10 times t. Right, so now I have to get rid of the e, so I'm going to take the natural log of both sides. So the natural log of 10 equals the natural log of 3 divided by 10 times t. And so now to solve for t, I'm going to divide. So I get the natural log of 10 divided by the natural log of 3 divided by 10. All right. And so now we want to do that calculation. So the natural log of 10 divided by the natural log of 3 divided by 10. All right. So I have the natural log of 10 divided by, now I'm going to use parentheses here, the natural log of 3, close parentheses on that, then divided by 10. And so now we get our value here, 20.959. And so t is approximately 20.959. We always want 3 decimal places there. All right. So first part is this answer, then 45,000, and then t equals 20.959. And the unit there would be hours, right? Because that's the unit of time that we are using here. All right. So that is problem number one.